Properties of families of the periodic table, TEACS C.5b. After this lesson, you will be able to predict properties of elements in chemical families, including alkali metals, alkaline earth metals, halogens, noble gases, and transition metals based on valence electrons patterns using the periodic table. This video is part 2 of a two-part series for TEACS C.5a and C.5b. When the periodic table is arranged by increasing atomic number, periodic law states that elements form predictable patterns of chemical and physical properties. Representative elements within a group or family have similar properties because each element has the same number of valence electrons. The periodic table families are alkali metals, alkaline earth metals, transition metals, halogens, and noble gases. The rare earth elements include the lanthanides and actinides below the main body of the periodic table. Let's take a look at individual families and their properties. Group 1 on the periodic table is known as the alkali metals. The alkali metals include lithium, sodium, potassium, rubidium, cesium, and francium. Notice that although hydrogen is in group 1, it is not an alkali metal. Alkali metals are silvery metals that are soft enough to be cut with a knife and are never found in nature in their pure form. Alkali metals have one valence electron in their s orbital, making them extremely reactive. This electron can be readily lost to form a cation with a +1 charge. Group 2 on the periodic table is known as the alkaline earth metals. The alkaline earth metals include beryllium, magnesium, calcium, strontium, barium, and radium. Alkaline earth metals are silvery, white, and have 2 valence electrons in their s orbital. They tend to lose 2 electrons to form a cation with a +2 charge and react less vigorously than alkali metals. Transition metals are in the D block of the periodic table. They have the characteristic properties of metals such as malleability, ductility, and conductivity, but are less reactive than alkali or alkaline earth metals. Transition metals tend to have multiple valences, giving up different numbers of electrons and forming cations. They can form a wide variety of compounds. The lanthanides and actinides are also known as intertransition metals, or rare earth metals, and are in the F block of the periodic table. They were taken out of the periodic table and placed at the bottom to make the table less wide. Many of these elements are radioactive and do not exist naturally. Instead, they are created in the lab. Group 17 of the P block on the periodic table is known as the halogens and includes the elements fluorine, chlorine, bromine, iodine, and astatine. Halogens have 7 valence electrons and tend to gain 1 electron to form anions with a -1 charge. These nonmetals are very reactive and bond easily with other atoms. They are rarely found alone in nature, but when they are, they form diatomic molecules, or pairs. The noble gases are in Group 18 of the P block of the periodic table. This family includes the elements helium, neon, argon, krypton, xenon, radon, and oganesson. They are all found in the Earth's atmosphere in small amounts. Noble gases are very stable due to their full valence shell. All of these elements resist forming bonds and have 8 valence electrons, with the exception of helium, which has 2 valence electrons. Now let's